share the screen. Okay. So guys, just as I told you, like Kubernetes will start with the intro and then we'll deploy app through pipeline. Now this pipeline we can use GitHub Action or Azure DevOps. So Azure DevOps need a subscription, okay, or Jenkins, okay, anywhere. So mostly we'll use first GitHub Actions, then we'll see through Azure DevOps, then we'll see through Jenkins, okay. So now you may ask, like, it's the intro part of Kubernetes, why you are using pipeline? So just as I told you, right, that we don't want to go in traditional way that we learn Kubernetes, then we learn uh, CI/CD, and then one by one. No, we will learn all together. That's how you can be compatible. Okay. Otherwise, if it would have been freshers, they can go ahead, they can take their time. But mostly all of you are in job switch mode. Okay. Some are in projects, some have to switch jobs. So it's better that agile methodology, this we can say, like uh, we'll start with. Okay. So we'll do all together. In that it can be cloud. Okay. We learned something about cloud. So we will start in that way so that it can be completed quickly. Okay. And as well as you should be practically prepared. Okay. It's not like it's a demo application. So even if you go to any organization, you can deploy by your own. Okay. So, okay, we'll start with Kubernetes. So I have downloaded one thing. Sorry. So this is the PDF file. Even I have made my PDF, but this is the PDF file which is very good for understanding. Okay, I'll share with you all. This I downloaded from uh, LinkedIn. Okay, of one of the members I used to follow. Okay, so and also I have my own Kub. So Kubernetes. Let me go ahead. Okay, so Kubernetes architecture. Why I will give some time to this. So even if you are 5 years experienced, even if you are 3 years experienced, even if you are 10 years experienced, even if for 15 years, this Kubernetes architecture question is common in every interview. Every interviewer will ask first, what is the architecture of Kubernetes? Some may not ask, but most of the thing that they will ask, like, tell me about the architecture of Kubernetes. Almost in 30 to 40 interviews I've given, they have asked at least 10 to 15 interviews, they have asked this architecture. Okay. So it's important, that, especially for the developers, you don't need to know all these things. But this is important for Kubernetes. That's why I'm going through. So Kubernetes have two components. Just make sure that it has two components: control plane and worker node. Now, what is control plane and why it's worker node? Okay. So you can consider this block. Okay. So okay, insert uh, shapes. Okay. So you can consider this control plane as the first box. Okay, this is the first box. Okay, and I don't know. Okay, yeah, fine, fine. This is the first box, and then again, this is one more box. Okay, so you can consider that first box is the control plane, and inside that is the worker node. But actually, it's not the case. Control plane is a separate component, and worker node is a separate component. Many of us think like both worker node is inside this. No, okay, so it's a separate, and together it makes a Kubernetes cluster. So why it is like that? So that is the architecture convention. Okay. So what is control plane? What is worker node? We'll come to know. But why Kubernetes? Okay. Why Kubernetes when Docker is there? Okay. Most of us will know Docker. Docker used to make containers, images, and all. Okay. So this question has been asked in many interviews. Like why Kubernetes when Docker is there? Okay. So you have to tell the first point is autoscale. Okay. The first point you have to tell. Hey, hello. Yeah, hello. Yeah, please. Yeah. I got a call from Arka Chakrabarti. Okay. From the his HR. So he told me send me up to documents. He has to get some approvals. Okay. So yeah, yesterday I shared. I called him and given the update. Like I shared with you all. He said like, okay, I will just check with the higher authority. I'll take the approvals and we'll come with you. So I'll wait. Yeah, yeah, thank you. Hey, sorry, this all came. These HRs are like anything. Okay, so mm yeah, so what I was telling, so both components include why Kubernetes. First thing is auto scaling. So in Docker, you cannot do auto scaling, right? I mean, through Docker, you cannot do auto scaling. Okay, so I'm not writing here. Okay, I'll give you the PDF. Otherwise, a lot of time is. I have a habit of writing and explaining. Okay, so I'll not do that because all the time will go in writing. Through Docker, you cannot do auto scaling. Through Docker, you can make a single container, right? Or if you have to make another container, you have to run another command. Okay. So exactly through Docker, you cannot do auto scaling, but there are utilities of Docker now came. Docker Swarm is one technology through which you can do auto scaling. Okay, but Docker Swarm is not much in use now. Kubernetes has come into picture. Now, why it is called It is also called K8s, right? K8s because between K2s there are 8 letters. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's why it's called K8s. So Kubernetes first thing is auto scaling. Remember that. Okay, auto scaling is next thing is you can tell whatever you want. Okay, next thing is like you can do the rollout very quickly. You can have high availability. Okay, you have good load balancer facilities, networking facilities there. Okay, the observability, the monitoring and logging can be easily integrated with Kubernetes, which is not in the case of Docker. Okay, so those things are very good. Okay, here. So these are the things you have to tell, which I will show you in PDF. Now we'll go to one of the component of control plane worker node. So why control plane? Why worker node? That's convention Kubernetes has given. So control plane is the component. So when you will install any cluster, okay. So this control plane components will be by default. So will be by default what it means. So these are the components which will manage your cluster. If these components are not there, your cluster will not run. You can consider that this is the machine and this is the motor which is responsible for running the machine. Okay. Now you got it, right? What is and worker node is like suppose in machine you are adding something, right? Suppose you are adding that this house should get lighted, that house should get lightened. Okay. So this is the worker node components. Okay. So control plane, Cube API server. So these are the four components that you should memorize. There's nothing like they will ask you like, can you explain the four components of, or can you explain the components of control plane? Okay. So at that time, you will not think about logics and all. Okay. You have to tell all these keywords: Cube API server, etcd, Cube controller manager, and I think this is a bit wrong. It's actually Cube Scheduler. Okay, both they have written Cloud Controller Manager. So I will just change it. Okay, one is Cube Scheduler. Okay, so I don't know why they have did this mistake. So this you have to memorize. If you can't memorize, write it somewhere so that in the interview you can tell by looking at it. Okay. So, and this components also you should, if you can't memorize, just write it down somewhere so that you can see and just tell it. Okay. But the logics and all you have to understand logically. Okay. So Cube API server. So Cube API server. Now I'll come to the PDF because this PDF is very good. Okay. So they have see they have done all things very good. So Cube API server. If you say Cube API server. Okay. And this control plane is also called the master node because this is the master because this is without this Kubernetes cannot run. So master node. So this is called the master node. Okay. So four components. See API server and etcd, controller manager and scheduler. These four components. Okay. So API server. So API server you can consider is as the heart of the Terraform. Okay. Without API server, nothing can happen. Your cluster can run, but nothing can happen. All the connections, whether I am connecting, whether some machine is connecting, whether some Kubernetes is connecting, somewhere, whatever the connections will happen, whatever the traffic will route, that will route through Kube API server first. Okay. If Kube API server is not there, you cannot communicate to Kubernetes cluster at all. Consider like this. Without API server, that's called it's called the API server. What API is responsible for? Connecting your front end and back end, right? And you are the front end and cluster is the back end. So API server is the heart of the you can you can use this word like this. API server is the heart of the Kubernetes. Without this, the communications cannot happen. So next comes is the HCD. Okay, what is HCD? So HCD is nothing. HCD is nothing but all the cluster configurations used to get stored. So you can consider this as the database. All the data used to, all the cluster config. Suppose you have kept two pods. So pods equal to two. Okay, in this part. So it will get stored here. Okay. So whatever you will do, that will get stored here. Okay. That's why it's called the HCD database. And what type of database it is? Key value database. Okay. It's not like a straight JSON file. Okay. I mean, can be JSON file, but it should be key value format. Okay. So that's it. Scheduler, through the name itself, you can imagine like what scheduler used to do. Okay. Assigns your pod to the node. And how it is getting assigned, we'll see later. Okay. Next is the next is the controller manager. So controller manager, what it will do? Okay. Controller manager is nothing but so it used to communicate with API server to see if the cluster is in desired state. Okay. Now, suppose you have kept the pods that two containers should be present. Okay. But in the cluster, somewhere it is three containers. So controller manager will check that why it is three containers. It will keep it to two again. Okay. So one container it will delete. Okay. So this is the whole architecture of the control plane components, which I will give you. Okay. So the first is the API server, which is responsible, which is the heart of the Kubernetes, which is responsible for all the communications from API server to scheduler, HCD, controller manager, or even worker node. Okay. So, and HCD is the database, which is used for responsible for maintaining the cluster configurations in key value forms. Scheduler assign node to schedules the pod to the node. Okay. Node means your server. Okay. Controller manager is used to see whether the cluster is in desired state or not. Okay. So now you know that what is the control plane components are there. Okay. So next is the worker node. Okay. So first is the kubelet. So kubelet is the component of worker node. You can consider is it's same what is kube API server in control plane. Until unless kubelet will know, nothing will happen in worker node. So worker node is what? Worker node is the component where your pods will get scheduled. Got it? Your pods will get scheduled, not any other, not the control plane pods. You cannot deploy in control plane node. Okay, you can only deploy in worker nodes. So here, if you see, there are only one worker node is shown, but there can be multiple worker nodes like this, and all will have three components: kubelet, kube proxy, container runtime. Okay. So back to the point, kube API server is in control plane, kubelet is in worker node. So kubelet is responsible for running your pods in your node. Okay, until unless kubelet is there, so you can consider this is the machine and kubelet is the motor. Okay. So this is and where kubelet will see. So suppose in suppose I have written a YML file that there should be two pods running. Okay. So how the traffic will flow? Connection will first reach to the API server. That API server will tell kubelet, see, I have two pods. Please run the containers. Please run the pods in your node. So kubelet will run the pods. So everything will communicate with what? API server. So kubelet is also connected to API server only. Now kube proxy. After the pods get assigned to the node, scheduled to the node, okay? After the pods get scheduled to the node, what it will happen? Pod should have IP. Okay, it should have the networking and all. So who will give the networking part? Who will assign IPs to the pods? Kube proxy. So you have to tell kube proxy responsible for networking and assigning IPs to the pods. Container runtime. So pods, if you know the basics of pod is the smallest unit of a Kubernetes. What is this? Pod is the smallest unit of a Kubernetes. Okay. Inside pod, there are containers. Okay. It can be container, it can be containers. Multiple containers can be there. So container runtime is responsible for maintaining the containers. Actually, what is container runtime? Container runtime is the runtime engine. Okay. And what is our runtime engine most of the cases? Is Docker. So container runtime used to be mostly Docker. So that's why Kubernetes contains most of the time the container runtime can be Docker. Okay, it can be Cryo, it can be Podman. Okay, so many things are coming, but most of the time is Docker. Okay, so you can understand that four components in control plane, three components worker nodes. So again, I will just revise. Kube API server exposes the Kubernetes API to every connection. Okay, etcd stores or cluster data. Kube controller manager maintains the desired state. It should be kube scheduler. Kube scheduler is responsible for assigning, schedule the pods to the nodes. See, kube scheduler is responsible for scheduling pods to the nodes. But who is actually running the pods in the nodes? It's kubelet. Okay. So it will schedule it. Then it will tell kube API server, please communicate to kubelet that I have assigned the pods to the nodes. Please run it. Okay. So it will go ahead and what it will do? It will run the pods or the containers. So sometimes I'm saying pods, sometimes I'm saying containers. Okay, so consider this similar because inside the pods containers are there. Okay, so if I'm saying containers are running, you can imagine that pods are running. Okay, so this is the whole thing of Kubernetes. Okay, now we'll go ahead to practical quickly. Okay, so uh, I have not installed any cluster, so there is the cluster. Where is the demo clusters are there? What's the name of the site? Killer Coda. Okay. So I'm just going to Killer Coda today. Okay. So there are some interactive environments in Killer Coda. Okay. So I have not installed today the cluster because I want to show you how to install the cluster, what are the things needed, and that will take a time. Okay. So I don't want to waste time in creating the cluster and then showing you. So better I will create the cluster first and then I can just go through the steps. Okay. So there are different types of clusters. I will just tell you about the clusters. So not much important to know, but people can ask you what type of clusters you are maintaining. Okay. So you may say that we are maintaining Kubernetes cluster, but they can say like what type of cluster you are maintaining. So at that time you have to say whatever, like whatever in your project. If your project doesn't have Kubernetes cluster, then you can say like we are using cloud managed cluster. Nowadays, maximum of the companies are using cloud managed cluster. On-prem clusters, no. On-prem clusters are just for uh, POC purpose, okay, or some practice purpose, test environments and all. Okay. So what are on-prem clusters? So Minikube is one type of on-prem cluster. Okay. Kind cluster is one type of on-prem cluster. Okay. But what are cloud managed clusters? So this I'm not writing because I will show you. Okay. So what are cloud managed clusters? So AWS has given its own cloud managed cluster. Okay. What is this? That is EKS. Then Azure has given AKS. GCP has given, Google Cloud has given GKE. Okay. And then many, I think Oracle Cloud has also its own. So mostly these are the cloud managed clusters which we are maintaining. Okay. On-prem clusters are very common that this is mostly used for. You can install through QADM. Okay. So if you do CKA certification, they will tell you to now they don't used to tell clusters, create cluster, but they will tell you to upgrade the versions of the cluster through QADM. QADM, then kind cluster is one cluster. Okay. Minikube is one cluster. Okay. So these are on-prem clusters mostly, which you don't use mostly. So right now, I'll show you how to install Minikube so that you can practice by installing in your own server. Okay. So AWS EKS. So this also will do. Okay. We'll install one EKS and we'll see that how EKS works. Okay. AKS and GKE, I'll not go through because maybe once the time permits, we'll go with EKS. Okay. So EKS is the so once you go through any of the managed cloud, you will be able to understand any cloud. Okay. So core concept is important. So we'll go to Killer Coda. So why I'm going to Killer Coda? Because Killer Coda gives you a ready-made environment of Kubernetes. Okay. So I'm just signing into Killer Coda. Yeah. You can also register yourself in Killer Coda. It's free. Okay. You don't have to give. Okay. So let me go. to playground. No, I don't agree with receiving marketing mails. Okay, so it already has the cluster deployed here. Okay, so now how will we use Kubernetes? Okay, so there are many ways to use Kubernetes. So one is kubectl, one is Helm. Mostly these are the two, and there are some GitOps tools as well, Argo CD and all. So this we will see later. Kubectl. Okay, so I'll directly go ahead. Suppose if you have to see how many nodes are there. Okay, kubectl, you have to say get nodes. Okay, so if you see control plane and two nodes are already created. Control plane nodes, you know what is that? That's the heart of the Kubernetes. Without this, your Kubernetes will not be able to run. Now, I told you that these components will be present, right? All these components will be present. Okay, how these components you will be able to see? If you say that Kubernetes is there and these components are already in use. Okay, so for that, you have to see kubectl, how these components will be installed. These components will be installed as pod. You're getting it? Pods. Okay, so if you will go to Kubernetes, okay. Now pods are of different types. Pods are not of different types. So there is something called namespace. Okay. So don't get confused that namespace something big. Okay. Namespace you can say like it's an isolated place. Okay. Isolated place. Suppose namespace dev. It's an isolated place. Namespace prod. It's an isolated place. Namespace QA. It's an isolated. So you can deploy your pods in dev namespace. You can deploy your pods in prod namespace. Okay. You can deploy your pods in QA namespace. All are isolated from each other, but it doesn't mean that all cannot communicate to each other. Okay. They can communicate with each other through services. Okay. So if you see how many namespaces are present. So the short form is you can write namespace as well, but I have a habit of using uh, kubectl get ns. So always remember the short forms. Okay. So if you see, these are the namespaces which is present. Okay. Cube node, lease, cube public. So you have to understand what is cube system. So these are the this namespace is responsible for holding all the parts of the system. That's why it's called system. So if we just go ahead, kubectl get, now what we'll do? Pods you can write or PO also you can write. Okay. Now for this namespace I want. Now suppose I am not giving namespace, I'm just putting enter. So it will always route to default namespace. Okay. But I want to see namespace in cube system. See, I told you right. etcd is one, Cube API server is one, Cube controller manager is one, Cube proxy is one, and Cube scheduler is one. So these are our main pods. Cube scheduler, Cube proxy, Cube API server, and etcd. And these are some core DNS pods which we will see later, but these are the main components which is present. See, we have not installed it. It got installed by default. Okay, so cube system, all components used to get installed by default, but we can use our own pods in this namespace. Okay, so now you understood like without this Cube API server, you cannot do this. Okay, and now you want to know the configuration of the Cube API server, how the Cube API server pod configuration looks like. Okay, now we'll go to the implementation part of Kubernetes. What is pod and how can we write pod YML and all. Okay, so let me go to the PDF. Okay. So this is a very good PDF. You can go through it. You'll be able to understand. You cannot go through it if you're able to understand here itself. Okay, this is very good. So now we'll go to YML file composition. Okay. So better I will write in that way. Okay. Rat new tab. So pod. This is the smallest unit. Okay. Pod contains containers. Containers contains what? Container contains your source code application. Okay. Smallest unit. After pod, that comes deployment. Sorry, replica set. Okay. Replica set. Okay. What is replica set? I'll let you know. Next comes deployment. So these three things you should know. Replica set is fine. You can ignore, but the logic should be knowing. Okay. Either you can get prod, either you can get replica set, either you can get deployment. Now, what is the difference? Pod is pod. It will contain containers. Okay. Replica set is what? Replica set. Suppose in one YML, you have to create two pods of similar OS, similar application should be deployed. Okay. So at that time, you can create replicas of pods. Okay. This is the thing. Okay. Now deployment. Now what deployment? So deployment also creates replicas of pods. You can create multiple pods of same configuration. Otherwise, suppose pod one you created and the same pod you have to create 4 times. Okay, so that high availability should be there. Suppose if one pod got corrupted, traffic should route to other pod. So you have to apply the command 4 times. But here you have to apply the command just 1 time and 4 replicas of pods will be created. Here also. But what is the benefit again? You can do rolling updates here. Rolling updates and also can roll back to previous version. Got it? This is the benefits of deployment. Okay. So it also creates replicas, but there is the advantage that rolling update used to happen. Now the naming pattern is very important. Okay. Pod, suppose you have created a pod with name, any name, demo pod. Okay. So it will be demo pod. The name will be demo pod. Now you have created a replica set called demo pod. Okay. I said replica set, two pods should be created. Now, what will be the name of the two pods? It will be demo pod and some random characters, AWSF. And one more it will call demo pod y2. So this two type of pods, some random characters will be attached to it. Whenever you create replica set, if 3 pods will be there, then will be demo pod hyphen. So with this pattern, you will be able to understand what this is. If you see the pods like this, your mind should go into the picture that it's a replica set. Okay. Now how the deployment will look like. Suppose in the deployment, you create a name called demo pod again, and I want 3 replicas of it. Okay. So how it look like? Now there's the catch here. Some people can ask you most of the if he's very good in Kubernetes, he can ask you this logic. Otherwise, it's not much a thing logic. Whenever you create a deployment, actually what it creates. So replicas it's creating directly the replicas, but deployment actually you will be able to see the replicas created. But actually in the background, what it used to do, it used to create a replica set of it, and this replica set used to create the 3 replicas. And how should be the naming pattern deployment? Suppose demo pod. Now there will be in deployment there will be 2 random characters AWSD hyphen HGDF or something, and one more pod 3 replicas demo pod something and one more, three replicas I told here because I mentioned three replicas. So whenever you will be seeing this naming pattern, you will be able to understand this is a replica set. But whenever you will be able to see this naming pattern, you will be able to understand this is a deployment. Okay, because this is a replica set is creating, and this is deployment is creating. Guys, whatever I discussed now, you are open to questions.
Nothing from my end, Risha.
Yeah, the guy you know already all these things. Okay, guys. Then we'll go ahead and take it as no. Okay. Now we'll start creating so that practically you will be able to know what is deployment, what are these things. Okay. So you may think like this is very basic things are going on right now, but actually these are important for interview purposes. So sometimes it used to happen that we have good right about advanced things and basic things. If I ask like how in the background deployment is creating the pods, they are not able to tell because they think like, okay, these are very basic deployment create. So most of the guys, what they used to tell, it will create the three replicas. Okay, but actually, what it is creating a replica set, and that replica set is creating the three replicas. Okay, so I will show you here. So either you can write the YML fully, or what, or you can write the CLI. Okay, CLI is the common way to write. Okay, so the pod YML, how the pod YML will look like, I'll just tell you. Okay. First thing is API version. This is a mandatory thing. So you know, right? Kubernetes, everything is happening through APIs. Internally, how the communication is happening through APIs. So every API has a version. Okay, every object. Okay. Okay, this pause, deployment, replica set, what it used to call actually, these are all actually objects of Kubernetes. Okay. So here the pod YAML API version will be V1. Okay. And then you have to write kind equal to what? Pod. Kind is pod. Then you have to write what? Metadata. Metadata, what you will write? Name. Okay. So what name you want to give demo pod? Okay. And now you have to write the specification. So spec. This is the short form. Now what will you write here? Spec. Okay. Now sorry. Here you will write the how many containers. Okay. Containers. Okay. First container, what will you write? Name. Next is image. So how many of you don't know about image? So image is like a text file where where you will write how your application code should run. Okay, through the image only it can make the content. Okay, so image, and the next is container port. What should where it should get exposed that you can write. Okay, so this is optional. Okay, first of all you can write this all these things. Okay, so you can just write this YML and how we should run it. Kubectl apply hyphen f whatever the pod YML name you have given, pod demo and all. Okay. So that dot YML you have to give. Or else you can create this YML through CLI also. You don't have to write everything because very difficult to remember, right? API version will be one. Who will remember this? This can be easily got in Google. But if any interviewer will ask you to write an YML file, what you will do? So clear. Okay. So kubectl run for pod creation run. What should be the name of the pod? Demo pod hyphen image. What should be the image name? Right now I am taking Nginx. Okay, hyphen image Nginx. What should be the namespace? I want to run in default namespace. Do we have to give this hyphen in default? Even if you don't give, it will be in default namespace. Okay, so if I enter this, it will create one pod. kubectl get pods. See, it has created one pod, demo pod. Okay. Now, what is this n? What is this 0 by 1? It means one container it is creating, and but it's not ready yet. Once it's ready, it will be 1 by 1. Okay. So now it's 1 by 1. So your pod is running. Okay. Now, if you want to check the logs of the container or the pods, you have to type kubectl logs and the pod name. Just the so this is the format. Okay. So there are many things in Kubernetes which you have to memorize. Okay. It's not like if you give anything like kubectl logs hyphen hyphen pod and demo pod. No, kubectl logs demo pod, it means exactly this pattern you have to give. Okay. Now, but I told you it directly created the pod, but I want to create the YML first. I don't want to create the pod. I want to see that YML contains everything or not. Okay. So kubectl, let me clear the screen again. Now, if I try to run the same pod again, demo pod with the name demo pod, it will throw error because it will say that pod demo already exists. Okay. Now, kubectl, what? Kubectl, I want to see the YML. Run. Same thing I will write. So this time let me do demo pod hyphen one. Okay. And hyphen hyphen image engines. I want to use a dry run. I don't want to use it. What is dry run? Dry run is like it will show you the YML. It will show you like how it should be created, but it will not actually create it. So hyphen hyphen dry run equal to client. So this is the format. Remember this. Why this dry run equal to client? Why you used to write? No, this is the Kubernetes developers have done it. So you just have to run that. Now hyphen O. What is the format you should be? Hyphen O is the hyphen output. What should be the format of the file you want? YML. Now I want this YML to redirect to a name called demo pod hyphen one dot y. Okay. Now if I do ls, there is a YML file got created. Okay. So if I just anything you can do, cat also you can do. Better I'll do VI because VI it will show in a better way. Okay. So VI is the VI editor, okay, through which you can open any of your files. So if you see how good it is, that you don't have to even write everything, it is automatically get populated. Now suppose you want to change like anything you want to change. So my image, I want to change it to MySQL. Okay. Okay. So it will be MySQL. So anything you want to, suppose I don't want this demo pod name. So what is this labels and all? So labels, I will let you know what is labels. Okay. So name is demo pod. I don't want demo pod one. I want demo pod two. So everything you can do, you can save it and then you can run. So now I will save it. How will you save it? Colon, WQ, and then exclamatory sign. Okay. Now you can just do kubectl apply hyphen f demopod.y. Okay. So it got created. Now if we do kubectl get pods, so it will be creating a pod. So guys, anyone has any issues in understanding? Yeah.
Risha, why are we giving that hyphen hyphen image nginx? Without that, will it not be created?
No, you have to give hyphen hyphen image.
No, why are we taking nginx only rather than that
No,
we
no, no.
cannot
You
go
can
with it?
create anything. Like that's why I'm saying that. That's
Mhm.
why I showed you, right? Uh,
Mm.
Here I have taken Nginx in this YML, but now I changed to my name, any image name. It can be ECR image also.
Okay.
Okay. That's why I'm saying like don't create the pod directly. Okay. You
Mm-hmm.
first
Mm-hmm.
convert it to an YML and YML, whatever you want to edit, you have to give. But something image name you have to give, right? While creating the YML. Okay.
Mm-hmm.
So you can give anything test or something and later you can edit. Okay.
Okay.
This is
Mm-hmm.
just to show you that you can run the pod directly if you know the image.
Mm-hmm.
Okay.
Okay.
So yeah, so you are able to know. Okay. Now I
Yes.
told you, right? This is a default namespace, but I want to run in different namespace also. So first I will create one namespace called dem. Okay. Now I want to create this pod, whatever this YML I created, right? Clear. Let's see how many namespace now. kubectl get ns. So there is a demo namespace got created. Now I want the namespace to be created in where? This demo namespace. Okay. So I already have the YML. Okay. vi demo pod.y. So now I want to create the namespace in the demo. So here you have to give the namespace in the metadata. So in Kubernetes, indentation is very important. If you put the indentation like this, somewhere you missed indentation like this, it will throw you error. Okay, indentations are very, very important. That's why never manually type the YMLs. Just copy it from somewhere or just write it in CLI mode, but never try to write it in all the YML. This is foolishness. Okay, namespace, and that is the demo. Okay. So now if I write, if I will just apply it, okay, kubectl. Now if I do kubectl get pods, okay, so it's showing that it's a crashback loop, or maybe the so is this pod whatever I created, is this the same pod it's showing? No, right? Because I am seeing in default namespace. I have to see in where? I have to see in demo namespace. See? One second, someone is calling me. Hello? Yes, this is Rishav. Yeah, yeah, please tell me. Which company? Okay, what is the location? Oh, actually, I'm not looking for Pune. I'm looking for Kolkata. For me? Yeah, actually, I'm looking for Kolkata. Oh, I've read it. Oh, oh, maybe I missed that, but actually I'm looking at it from Kolkata only. So I'm looking for Kolkata. So EY is in Kolkata also, right? Okay, let me know if you have any for Kolkata. Yeah, thank you. Okay, guys. So crashback loop. Now this error is coming. This is a very common error. This is a very common error, and people will ask you, like, suppose if you are checking crash loopback of error, what? How will you debug this? Okay. So first of all, we'll check the logs. Kubectl logs. Hyphen n demo. Okay. So see what it has given. Entry point for SQL, switching to dedicated user entry point, database is initialized, is not. 1 second, guys. Hello. Yes, Miss Rishabh. I'm doing good. How are you? Yeah, what is the company name? Okay, okay. Okay, okay. Yes, please tell me. Yeah, because here the opportunities are very less, and you have to wait for hours and hours to get one opportunity, notice periods and all. And I believe like my technology is like that, which is more proper in abroad. So cloud and all. Sorry, PR. Um, no, I don't have any visa right now. No, not quite. Yeah, yeah, I'm okay. Canada, Canada. Yeah. Yeah, but is the company not giving whatever I will be selected? But I mean, is it like what I have to do? Okay. Oh, yeah, sure. Yeah, yeah, same number. Yeah, sure. I'll send you. Hardly 10 minutes. Okay, okay, sure. Thank you. Thank you. Yeah. Okay, guys. So sorry. So you have to see that we have to mention something like environment variable. Okay, so we'll just go ahead and we'll do these three things. Okay. So how we used to mention an environment variable? Okay. So you have to mention like this. These all things you can remove. Something called environment. Okay. And you can copy all these things. Okay. I think we have to give something like this, this, this. One second, let me see the how the environment variable is to get mentioned. And here you can give like text. Here, so you can give like nothing. Okay. Root password. So this password you should not actually mention here. Just to remove the errors, I'm just showing you like how it should be. Okay. So you can see the indentation. How is the indentation, right? So let's see whether it works or not. So we have to delete the pod, otherwise it will show the error what that already pod exists. How will you delete? Delete pod, whatever the pod name is, demo pod 2, right? Whatever pod name is, we have changed to demo pod 2. Better use hyphen hyphen force, it will immediately delete. Otherwise it will take time. Okay. Now we'll do the apply kubectl apply hyphen f. What was that? YML name? vi demo pod. Okay. Again, there is some issue. Request is invalid. Okay. So these are the things which is all the format issues there. So so this you can create through Kubernetes docs also. So once you will give the certification exam, right? So they will give you the documentation to write. Okay. So at that time, you should not use your own brains. You should directly go and check the format. Okay. Like what is the format? So if you see here, environment variables, how this should be there. See, I was giving here demo greeting, but it should be like name value format. So this is the format you should follow. Okay. So after that, it will be resolved, this issue. Let's do it so that you will be able to know like what is the format. So this is not the format. The key value format should not be like this. So how it should be? It should be like this. Yep. Right? N hyphen name and see the indentation where I was giving the n in the indentation of containers, but it should be in the indentation of the name, image, and n. So one mistake I was doing there. Okay. So this debugging you will learn. Okay. If you're not the debugging, then Kubernetes is all about debugging. Okay. Simple issue will come and you have to resolve this. Okay. So environment name is what was that? MySQL root password can be 12345. So I'll show you like how to hide this also. Okay. And next is empty password, and it should empty. I will keep it empty. Next is again hyphen name. Sorry, our name I put. What is this? I just put it R. Oh, something is there. Something. I am putting N only. I just keeping it. That's fine. Let me copy this. This. So, and next is what? Random root person. This also put something like this. And we'll remove this thing. So, suppose so many lines are there, right? So, what it will do, we will not do like this. We'll just put set number. Okay. And see, I want to delete from 14 to 17. Okay. So, you will write like this. Okay. Again, you will put colon 14 to comma 17 and you'll put D. Okay. So, it will delete. Okay. So, see. So, this will make you more easier. Now, you will save it. Okay. Okay. Now, we'll run the what? Forbidden parts may not change. Something is missing. Oh, there is some tolerations out there. Not sure what. What is this? For image activated aspect toleration. Media applications. Service account expirations. Downward API. What is downward here? Not able to see what is downward here. Okay. Oh, we have to run in demo. Okay, okay, sorry. No, it should be in demo. So, kubectl. There is pod, I think, already existing. Let me delete this kubectl. With pod demo pod hyphen 2 hyphen force. Okay.
While applying also, can you give the
Yeah,
names
something.
right now?
A namespace I'm already giving in the pods. Okay. So if you see, namespace is demo.
Uh-huh.
That's why we don't have to give there. Okay. So anyways, there are some issues. Uh, Maybe this Kubernetes cluster is not up to the date also because it is showing that forbidden. We are not pods. Updates may not change fields like spec containers, spec init containers. Where is init container I'm creating? Okay, so that's why I will create my own cluster. This cluster has so many restrictions. Problem is that okay, identical fields and all it's showing. Right? Already the I have deleted the container, but it will still showing that class loopback is there, which I have deleted also, but not sure why it is showing. Delete pod demo pod hyphen n demo. Okay, I think I have not done hyphen n demo. Now it got deleted. Let's see. So you got the issue right now. So now, so how we debugged? So we debugged and lots of issues we came. So first issue we put is crash loopback off error. We checked the logs. We checked the logs and we saw that this SQL pod will not run until unless we'll mention these three fields in the environment variable. Okay. Now we did the environment variable, but it threw error that this request is invalid. So I got to know that there can be some indentation issue or some format issue can be there. So we just check the actual environment variable format. Okay. So this should be the format actually. Okay. We again did that, but we saw that this issue is this again it is failing because there is some error like forbidden because it's not allowed. Why it's not allowed? Because one pod was already there. So I deleted the pod, but what I deleted, the same name pod was available in default namespace. So I deleted that pod, but not in the demo namespace where the YML was trying to getting created. Why that YML was trying to create in the demo namespace? Because we have mentioned this namespace should be demo. Okay. So again, we deleted the pod, which was the crash loop back off, and we deployed the pod and it got deployed now and it got running. So this is the thing. I will stop here because lots of things I have done. I'll just stop this recording also. Okay. Uh, Stop.